All of our videos here are brought to you by the Landscape Certified Contractors Association. Due to the membership support, we're able to bring these videos to you each and every week. If you'd like to be part of our organization and help us bring these videos to you, make sure you visit www.irrigatortech.com and have a great day.
260 videos on there, so if you want to learn how to trim plants, trim trees, chemicals for your CEU credits, anything like that, backflow repair, we teach backflow, everything and all the procedures are on there. You can just watch those videos. We normally do, what, 3 to 5 videos a week, Brandon? Yeah. So we're always out there. You'll be able to see this video and see yourself in it in probably another week. So we'll be showing this one. But we're always going over wire tracking, electrical troubleshooting. That's a pretty big class for everybody. But if you want, it's in Spanish too, so you just hit the Association of Latino Professionals, and that's us as well. So we have an association just for guys that do Spanish. So you can learn how to trim trees, do the irrigation, fix valves, fix everything, and it's all in Spanish there as well. So welcome everybody. I'm going to be cramming a lot of stuff in. We have a lot of different things here. It's hard to cram 4 hours into an hour and a half. So if you guys want to take a regular class, you're welcome to take any Irrigator Tech classes. Go to our website, check it out. We're always traveling all over the place. We do them in Anaheim every Saturday. So you can take Saturday classes too. So we're always doing those on Saturday, so you can come. If you have a place that you want to host classes, like you say, hey, come out to the city of Palmdale or Arizona. We go to Arizona at least 4 times a year and do classes there. But if you guys have a place at the city, the cemetery, any place, and say, hey, we want to host a class, then you just call us up and we'll come right out to you as long as we can invite other people. So if you say, hey, we want a tree trimming class and then training on your chipper safety, chainsaw safety, all that stuff, just say, hey, we're with the city of so-and-so, UC Irvine, any city, college, we'll come out and do it. It's called a lunch and learn, and we do a whole training on that. You'll see everything with steel and everything on all of our videos. So you can watch that, and that's free to you guys all the time. Anything that you miss in troubleshooting that I can't add in, I'm constantly talking about the equipment and doing more and more stuff on wire tracking. So whatever we can't catch now, we do. We go out in the field. We did one up, where was the one out in Palm Springs? What was it? Beaumont. We went out there and they had valves that didn't work for what, 6, 7 years? And by the time we finished the series, we had wire tracked and fixed all their valves in the field and did everything. So if you've got a park or something and you go, hey, I want to do a hands-on, it's great to go out to your parks and then we'll do the class out there and we all wire track and learn together. That's the best way. This is the hardest way, just talking about it, but at least gives you some kind of education. The best way is breaking into groups and wire tracking right out in the field and using the tools. The more you use them, the better you get to get used to them. Let me set this down. Can you guys hear me just talking regular without this microphone? You guys are okay? Yeah. So I started Irrigator Tech. Oh, it's been since, I guess, it was actually 2000 with this PowerPoint. So I do all the Irrigator Tech stuff as well as Brandon, and we have 2 Spanish instructors as well. Danny will be doing a class tomorrow, and he does them in Spanish, and so does Hugo. So you don't have any books. Normally in this class, we give you a book about 2 inches thick, and it's all through wire tracking and stuff. So I'm just going to go through the normal. Does everybody use ohm meters? Okay, I'm going to go through a little bit of the ohm meters just on here. You got the CMT80, which is a good ohm meter. That's like this one right here. And you guys can come and look up after the class, or you got your standard ohm meter right here. So we got toners and receivers. We're going to talk about pulsers and all your equipment. If you have to use your phone, just step outside. If you come out this way, go around the corner, there's a restroom, so feel free to get up anytime. And respect all the tools that I got sitting around. So in the class, there's always a flow chart. So with wire tracking, we always want to wire track methodically, 1 step at a time. Unless it's a project that you've been on all the time, you never know what someone's done before you. Okay? So the rule of thumb, if you're a C27 contractor, you're always supposed to use your red and your black for your station wires. White is always supposed to be the common. Okay? But we kind of, there's no inspectors or that many inspectors, so we kind of do whatever the heck we want to do. So you can get out there and see different colored wires, different stuff. You just don't know for sure what people have done. So we have a flow chart, checking the master valve, doing one step at a time. So back when I had a technician company, in the 70s, I basically had these same type of books that I would have, and then we do sell the books on telling you how to wire track. But methodically, I could ask anybody in the field. You can call us. You have my 800 number there, and I'm going to say, did you check this? Did you check that? And you got to go step by step. Now you think no idiot would have done this. In our industry, I hate to say it, we got a lot of idiots. There's a lot of people that mix wires, move wires, don't put the wire connections on correctly, go from 12 gauge to 14 gauge, loop wires, jump all sorts of stuff in the field. So a lot of times when you got something really difficult, you'll have to start all over and just go one step at a time. So it's always nice, like if you were going to go to McDonald's, I've eaten all over the world, and I've been in Indonesia. The French fries, I'll tell you, taste exactly the same as they do here, because they do the recipe right. So what you have to do is have procedures on every process when you're a repair technician. If you're doing backflow, procedures are the same way to test them. So we do backflow certifications, and you got to go one step: notify, identify, inspect, and observe, and then check every single thing. Same thing with wire tracking, more than anything. And we're going to go over that each step at a time that you need to do. Okay? So you have the old style multimeters, where it has that little digital piece going back and forth. I like the regular type, more instead of the analog, the digital. It's much easier to work with. When I want to put it on and get 24 or 36 ohms, whatever reading, I want to be able to see it right away. So you've got it here. You're going to hook up the minus, just like a car battery. You got a minus here, and then you got the plus with the red wire. So you're going to go one step at a time. So you hook up both. You have this here that's going to ratchet back and forth. Or you got an auto ranging one. So there is the CMT80 or any of them where they're auto ranging. Those are the nicest ones. They're normally $100 to $150. Most all your irrigation distributors would have it, or you can purchase them online. But this is just one that you would click over and check and go, hey, I want to check this, check that, and you turn the dial as it goes. Now, if you take your ohm meter, and all you do is with an auto ranging one, would be like this. So all I have to do is press a button here and it goes in. If I stick in, so auto ranging is AC, your AC voltage. Every single time when you go to the plug-in here, you're going to have your AC, which we call it's 110. I don't think I've ever had it be 110. It's usually 112, 118, 121. It really depends on what you're putting in and how many sockets that you have hooked up to what that's pulling from. Okay? So I always want to check, what is my clock hooked up to? Okay? I'm going to pass this around so you guys can take a look at it. This is a Greenlee one. The Amada has one. Lots of people have them. But you want to be able to take it, you push one in one side, one in another, you should get a reading of 118, 119, 121. Okay? Does everybody do that when they go out in the field? So that's what you should be doing. Okay? If you don't have an ohm meter, you should be buying one. Okay? You can check the DC. So we have all the battery operated units in the field. You've got the Hunter one, you've got the Hydro Ring one, you've got the Rainbird one. It's 2 batteries. The wire's red, or the wire's black. Red has to go to red, black has to go to black. It sends a pulse. They're called latching solenoids. So it latches and the magnet pulls it up. You can leave it on for 4 hours, 10 hours, whatever you want. Then it sends another pulse and pushes it back down. Okay? So that's how battery operated units work. Does everybody use battery operated units in the field? okay? Battery operated units, which, let me see if I got a picture of them. Let me go back. So a battery operated unit is going to be used for your troubleshooting. Okay, if I'm a technician, I'm in the field, and I got lots of jobs going, I got a hole that's over here, and I got another hole I got to get to, and then they say, hey, somebody put a fence post or a sign in on the homeowners association or at the park, the wires aren't working, it's brown, it's dead. I will go out and tell them, hey, at the end of the day, I will go out there with a battery operated unit, turn off station 19, hook it up, and I'll be able to come back a week later if I'm booked. So I use battery operated units when I was wire tracking, had all my guys use them as spares just to help me out. Very seldom can you wire track and fix it really quick. In most cases, has everybody wire tracked here in the field? Yep. Doesn't it take quite a long time, and it's pretty frustrating? Okay, and when you push yourself to try to get something done even quicker, you get more frustrated. You want to throw the machine away and say, hey, this stupid thing doesn't work. You have to take your time and methodically wire track one step at a time. And if you don't have the time and think, hey, I got at least to have 2 hours. So in most cases when we wire track, I tell people I can wire track and find any wire break or any field break within 2 hours. Anything after 2 hours, I tell them you don't have to pay me. So when I use the wire track, that's what we always put out there. So you have to really get good at it, because most people don't want to get a bill for wire tracking and it's 19 hours and 2 wire nuts. You know, they're looking at it going, oh my God, this is $1,800. Couldn't we just put a battery operated unit? You go to any distributor and you will see Hunter One, Hydro Rains, Rainbirds, Digs, everybody's out there. Because everybody wire tracks and they can't find it, so just put a battery operated unit on it. It's really cheap. You charge them $150, $200, and you're on your way. But with water management being really, really a big thing now, you can't go out and audit, you can't go out and water manage if you've got yourself tons of them. I was at Pitzer College, that's up on Foothill, and they said, we want you to come and teach us in a class, 4 hours. I go out there, there's 19, 20 people. I'm like, oh my God, there's a lot of guys here. So we just went out, and what they had me do, instead of going over the pound, I just wire tracked for 4 hours. They had over 390 valves, and more than 250 of them were all battery operated units. Just over the years, that was their habit. Just switch it out, put a battery operated. Switch it out, put a battery operated. And it was just stupid little things that they had done over the years and got spoiled, and once that habit was created, just go down to our local distributor, buy one, and then put it on. Go do it again and again. Now, a lot of them I found within 2 feet, 3 feet from the valve box. And what ends up happening on wire tracking is that the solenoid goes bad, it overheats. Like if somebody turns off a backflow. If it goes a couple days, you'll see your wire start getting little black marks on it. I don't know if you ever noticed that. You'll see it starts turning gray. Even on the black will turn gray. Then when you take the wire nut off, it'll be green in the inside, it'll be different colors in the inside. That means the moisture, it overheated. So in the class, I normally take a clock and right at the beginning, put a transformer on, got my transformer, and I start giving it 24 volts on the table. And within usually 30 minutes, the wire starts burning back. So the solenoid bubbles up, and then they're water cooled. The solenoids are water cooled. So I'm not giving any water, just setting it on the table. And then what it does is it starts transferring the heat on the wire and starts burning back, and you get that's what those little gray marks are. It's burning the wire back. So the farther it burns, it starts destroying the wire. All of a sudden it's a foot back, then it's 2 feet, then it goes 3 feet. It changes the molecules of the copper wire itself. We do a soldering and brazing class, okay? If I take a brand new copper fitting and I hand you a pair of channel locks, I say, bend it. You can't bend it, okay? But if I heat up that fitting, the copper fitting, and I go now bend it, as it's heated, it just crumbles. right? We all know that. Because I changed the molecules of how that fitting was made, and it's now softened it. And that's what we've done with the wire. We have softened the wire that's traveling down, and the longer we leave that solenoid being bad, every day it heats it up, goes back. So if it's running for 30 minutes, and it goes 4 or 5 days, it just keeps on heating the wire. I've gone 40, 50 feet, cut, and then I found, like if you're pulling and it's snapping, when you're trying to get it on, that means it's melted the PVC coating. So you ever notice when you're trying to put a new wire on, you go, man, I can't even get the coating off, right? You're pulling it off and you go, man, it's a pain in the butt. So you cut back a little bit more, you're pulling on it real tight. That means that wire is overheated so much it melted the PVC that's on the outside coating right to the wire. That wire that's inside the copper is no good anymore. So what happens is that you send the 24 volts, you go, okay, I got it down, and you go, hey, I got 24 volts, but it doesn't pull up the solenoid. What's wrong with it? Why isn't it working? It's because it's sending 24 volts, but the ohms on it is not going to pull it up. If you look on a solenoid, it says inrush holding. That means it's getting the 24 volts, and the inrush is pulling the plunger up and holding the plunger up for that with 24 volts. If the copper's been compromised by being worn out, it can't do that. It can send the 24 volts out, and it can be there with your little ohm meter, and now you're checking it, 24. Oh, what's wrong with it? You're checking the clock, it's 24 volts. You're checking the wire, it's 20. Why? Now do an ohms test on it, and you go, hey, right over here at the next valve box, I'm doing good. I got 28 ohms. I got 23. I got 32. But then when you get out to the field, you're going, wow, it's up like 90 because it's been overheated. So you have to dig back away from the valve box, pull the wire until it's soft enough where you can take your wire strippers and just pull it and it falls right off. You know how new wire is. You're just like, hey, this pulls off really easy. Then make your connection. Sometimes I'll just wire track maybe 5 feet away, find the wire, dig down, 5, 6 feet away, cut it, and I'm all, it's nice and smooth here. Cut it, just put a jumper wire over the solenoid. Hey, if you guys want to dig it up, you dig it up and just replace this wire right here, I'm done. You know, I'm all like, hey, you want to charge, we went out just recently, Brandon and I, $100 an hour to wire track, minimum of 2 hours. I'll get it done. Anything over, you don't have to pay. And they go, oh, this, that. And I go, hey, just methodically, let me do, and you just watch. And I go through, oh, don't move the wire. I did this, I did that. And I'm like, just let me do this. I know the recipe on the cookies that I'm going to make. You know, I know the way I like my cookies and the brownies. Just watch me. And they're going, oh, my God. And I said, well, you've messed around. I can tell you moved all the wires now that you don't even know what's what. And I'll put the wires back where they are, and then I go, see the reading, see the reading. How do you know that? I go, look at the meter. When you do an ohms test, well, I got 24. I go, it's overheated. We go back, I wire track from there, and I can go to the valve box. Now, if it's close to the solenoid, I do not wire track from the clock out. So if I hook up the 521, right? You guys all know I will walk away from the camera, but let me get to the 521. So this is your resistance, okay? So the wire's coming up. Every time we put a wire in that, I'll go back to the 521, I haven't forgot yet, okay? I'm just getting ahead of myself. So here's your power, it's coming out, we put a wire in that. Okay, I gave you a bunch of wire nuts, they're around here somewhere, the little gel caps. Now remember, when you take those gel caps off, you throw them away, you don't put them back on again. Because if you got that white goop and all the goop all over your hands, then it's not in the wire nut anymore. So a lot of people take them off, put them on, take them off, put them on. No, you throw it away, put another one on. That's what you're supposed to do. So every time you put a wire nut on and you twist the wire, you're now changing how that electricity travels, right? You're changing the whole thing. So let me see. Okay, so how does it change? We know if we have a lake here and the water starts to come down, this is where our pressure started. It starts to travel. We got flow, the water's moving. When we put a smaller pipe, this is a 10-inch. If we push it down to 1/2 inch, we got friction loss, right? Okay, that's the physics of water, right? The more we push it down, the more we don't gain pressure, we create friction loss. So if you got your hose and you're in the front yard, to make it simple, and you're hosing down, which we're not supposed to do now, but you are hosing down, okay? Then your wife says, hey, I got a beer and the soccer's on or baseball's on. You kink it, put a fire nozzle on it, one of those long nozzles. Man, it's just shooting the leaves off the grass and then cleaning up real quick. I'm going to go in. Did you change the pressure? No. You changed by creating friction loss. That's all irrigation is. You got a valve at your front, an anti-siphon valve that's 1 inch, and now you're pushing the water through all these fittings, and then it's coming out of a little nozzle, your MP, and it's spinning. So that's all you're changing is how that water flows. That's exactly how voltage. We're over at the panel with all the breakers. We're checking it. Boom, 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 boom. Now, I always check the panel right there. Now, if I go down the breaker box, and it says pool lights, tennis court lights on the breaker, front gate, and irrigation clock. That's considered dirty power, okay? You want to have one breaker on one unit, okay? I was doing Chaffey College. The guy Daryl called me up. I repaired a clock for him. This was several years back. And I gave it back to him. He says, hey, it doesn't work again. What? Okay, come pick up a panel, I'll give you another one. So we do an exchange panel. You can call us up and say, hey, I need a couple panels, give me a CalSense, a Rainmaster, a Neutral, and we just exchange them, boom, you're ready to go again. So I give them another panel, it does the same thing. Something's wrong. I go out there, and they put a new cubicle in, and they have all these computers hooked up to one breaker. And everybody's in that room, all the kids are going, bing, the electricity goes off. Bing, just too much. I go, hey, where's the electricians? We pulled off, changed it, put it on its own breaker. He never had the problem again. So you don't want to have, when you go to a condo, an apartment, anything, if the Little League at your college or the school district, and they go, hey, I got the hot dog machine, the nacho machine, the snow machine, cone machine, get it off that and only have, because they got the scoreboard going, the one on the clock. It keeps it clean so it's traveling. When the water, it's like opening more valves all at one time. We open one valve, it's fine. All of a sudden we got 8 valves all opening at the same time and we're using 1 inch. You have nothing at the end to open your heads up and they're all just bubbling, right? You can't open all 12 valves at one time. Nothing, just all like droopy, just hanging there. But if you turn them all off and open one, now you got the circuit, one, boom, they pop up, spray. Pretty simple. So think of it that way. We only want to have 1, maybe 2 things on a circuit, especially the front gate of a homeowners association, because that's opening all the time. And then someone, you got 100 people in an apartment, they're always opening. At the college, that gate's always opening. You don't want to have it hooked up to the clock at all. So we want to make sure we have clean power. We want to make sure when that electricity is traveling, just like the water, it's current. Like it's going down the Truckee River, man. It's just going down. So when electricity moves, it's current, right? And then we put a wire nut on. We have resistance. Every time we put a wire nut on, it raises it. So I go to a valve box. When I'm wire tracking, I open it up and I go, this guy changed the solenoid 3 times here because he never wanted to cut the common. There might be 2 valves inside of there. Instead of cutting the common and then replacing the solenoid, he just takes the wire that was on the solenoid, cuts that, and hooks his solenoid wire to that. And there's another wire nut. Right? A lot of people do that. You have to cut the common, and you have the loop that goes to the next valve beside it, and the loop that's going to the next valve, right? And people go, man, that's just like 4 wires. I don't know, that's a big wire nut. So they cut the little wire nut and add another one to it. So now you got 2 or 3 or 4, and I'm all like, hey, get rid of the wire nuts. I've gone out, opened the valve box. They go, what are you doing? You're a wire nut crazed person. I said, you should have 2 for every valve. That's it. You got 6 on this. I cut it, clean it, put a new wire on it. Bam, it works and it comes on. Oh my gosh. I go, nothing fancy. You got too many wire nuts on the same valve. So you got to remember, you learn that 1, the heating of that wire is bad. So the more wire nuts. So when I take that 14 gauge wire, so you're always supposed to use 14 gauge hard, right? I mean, that you're going to be using a direct burial. And you're twisting it, and then you put the little cap on it and crunch it, and you can snap in, you can use the wire nuts like this. You want to have it so it's completely, and always check when you twist, move it. I've had people, I've gone there and they go, yeah, I just put it on a new install and it doesn't work. And I gone out there and they twisted it and they broke the wires and they were just hanging there in the first place. I go, that wasn't a wire nut, you just went too much. So twist them, leave it long, then cut it short, put the little copper piece on it, like on your DBYs, crimp it, stick it in the gel cap, snap it, or the dry sack. Does anybody use that little baggie with a dry sack that 3M puts out? Have you ever seen it? Where there's two, you've seen them? Where there's two chemicals, a clear one and a dark one. You put the wire, you put it in, you snap it, you jam it in that and move the two chemicals together, it'll heat up and it'll expand right there and it's rock hard. Nothing gets in it. You cannot use gel caps, regular little wire nuts when you're putting in a flow meter, right? When you guys see flow meters in the field, and that flow meter is going back to the clock going tick, 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 telling how many clicks. And those clicks add into the paddle wheel spinning to tell you how much water is flowing through that pipe. If you don't have a good connector, like one of those little dry sacks on it, you got some loose little wire nut or tape on it, it's not going to send the pulses. We were just out on a job that was at the FedEx building. Wasn't that right, Brandon?
Yes.
2-wire system. Been put in over a year. They can't get it to work. It works, it doesn't work. It works, it doesn't work. The contractor's gone, now the new maintenance guy's there. Hunter's been out there, Dan Kamicki, or I think I missay his name, but Dan's been out there. And it's not their problem. The clock's working, everything's working in the field, their units are. But instead of using on that 2-wire system and using 2 wires jacketed, the little blue one where it goes down, they use 14 gauge wires. And when I opened the valve box, I went over and just touched them and all the wire nuts just fell off. I go, you can't do that. You have to run a ground to every single connection, to every single 2-wire connection that you have. If you don't have a ground there, it's not going to send a pulse. So they had 80 stations. So when it goes down, if the first station goes down, it doesn't go to the other 79 stations. So they had a bad connection there. I go, oh my God, where's your grounds? Oh, we got like 2 over here and 1. I go, what, you're talking 4 out of 80? Oh no, that's, you got some mad. You have to go back to the irrigation consult architect. Let's go look at the spec sheet and see what they did. So it was really the person that installed the job, there were some real mix-ups. They did not have the proper stuff in the field and did the job right. So your connections are super important when you're in the field. You want to tighten the wires, pull on them so they don't unsnap, and make sure they're completely in the gel enclosed. Because if not then, later, that's what happens. People bury wire nuts down in the ground, and 2-3 years later, they come unloosed. Usually when you're wire tracking, it's usually a one that's doing it. I tell people when you install, never buy smaller. People go into their distributors and say, I need 1,000 feet of pipe. 1,000 feet of wire. Oh, we just sold the last couple rolls. We don't have 1,000 feet. You can get 2 500s, you can get 250, 250, 250. Say no. I want white or black or red, and I want it to be one solid piece. Because if you get 250, 250, that's 4 wire nuts. After 7 wire nuts, it's already moved you up. So it's drawing too much. So the ohms reading, when you get, in my class, I set out a wire, and I put it on, and I show a regular wire that's solid. Boom, on one side, and at the end, all the ohms are good. We cut it. We cut it again. We cut it again. And you get past 7 cuts, the ohm starts going up. The ohm starts going up. So if you've got some gopher problem, and he's 8 over here, 8 over there, 8 over here, and you now have 14, 15 breaks that he's done and you fixed, it's almost better to run new wire. You have to be able to cut your losses on wire tracking too. I've had people say, oh, well, I'm digging into the tree, and I said, man, that's a 100-year-old oak tree. Stop over here 50 feet away and dig around it. Skip it. Because I've got pictures inside the cloud, I'll get to them. where the wire is just stuck in the tree. You know, people go, oh, well, I'm hacking at the tree. I go, at $100 an hour, you're hacking at a tree? I tell people, cut it here. I run a jump, dig out, I track to the closest part of the tree. I got clean wire. I go from the valve and come back. I say, I'm clean here, clean there. I run a wire on top and say, look it, right here you got 75 feet of wire because we got to get around this. If I fix it, here, boom, here, everything's firing. My recommendation is just to dig a trench around here and put a new wire. You will waste hours of time going through upland. I don't know if you guys know where upland's at. Rancho Cucamonga, it is solid rock, and you'll be trenching and then axing at a tree, destroying the tree. So it's much better to say, hey, I put 2 hours in, I got you to here, I got you to there, and I ran the jumper wire. You need to send out a crew and dig around this thing and get over here. Okay? Don't spend another 5 hours digging through big roots and wasting people's time. I like to get right to the point, wire track, find it, and get it done. So everybody understands the process, that electricity and water travel very similar. You've got your high voltage here with your breaker, and then it comes down as current, like the river, and then every time you're putting, the less wire nuts, the better it is. One straight run. I work for the city, or I'm at the cemetery, or I'm at the golf course. Give me 1,000 feet. Give me 2,500 feet. I got one here, got one there. I don't want to have anything in between there. The least amount as possible. Any questions? Everybody fine? Am I going too fast? Okay, there you go.
You say no more than 7 wire nuts, but say you have 40 stations.
On that one run. If you're running to a station 14, you don't want to have 12 or 13 little pieces of wire. Is everybody okay with that? You want to have one solid run, unless it's over 2,500 feet.
So I would say the common, you're going to get a bunch of...
That's why a lot of them, you'll size down the wire. Okay? So if you start to get long runs, we're using your 14, right? You can go to 12. The farther you are away, that's what we do with pipe, right? Okay, so when you take PVC pipe, and we're starting off and we got 1.25 inch pipe and we got a long run. If I want the last head and I'm going, let's just say I'm going 2,000 feet away. If I want the last head to be equal to the first head, I run the 1.25 inch a majority of the way, then I go to 1 inch, then I go down to 3/4, and the last one's put on half. When I check the last head and the first head, it's about very close, within 5 psi. That's what it should always be at. Okay? If I use the 1.25 inch all the way down, I got the volume, but now the head can't shoot the same on each one. That's how your irrigation's working, right? So pressure compensating, if I put a pressure compensating nozzle or a screen, what it does is the first head gets a lot, and then it just shoves it to the next one, then shoves it to the next one, and equalizes so the first head and the last head is only within 5 psi difference between each one. Same thing with wire nut. I want to try to get the wire to be the same. So that's why you go through a chart that's in the back of every book, and it tells you how to wire size. I mean, when we do audits, you know, you check and someone's done something wrong. There's no harm to call an architect, hey, you know what, I'm just a landscaper, but why is I'm running a brand new system and I can't get it sized right? It's just that landscaping and maintenance people don't ever ask. They just run the whole thing 14 gauge, or they run the wire the same, and gospel is the architect and the irrigation designer. You know, they make mistakes, we're all human. You say, hey, you know what, I just want to learn, am I doing this okay before I bury it? You know what, maybe I didn't calculate it right. So what an architect and an irrigation consultant does is they design everything, calculating how much pressure is going through the system, how much friction loss is going through a valve, and how much friction loss that's going through every head. So if I dig up a line, think of it this way. I've done an audit, which she's done tons of audits, and you dig up a head and you're thinking, okay, I got the right PSI here, and you're checking. Going down, this one's real low. You got the same nozzle, and then all of a sudden you dig it up, and instead of having 2 Marlex or 3 Marlex, they couldn't get the head right when they repaired it. So they got 9 Marlex. That's like putting 9 wire nuts on a wire. You're like, hey, one's not good enough, just let's put another on. But they wanted to get the head right. So what you use is you can use the Hydro Rain, the Blue Lock swing pipe, you can use funny pipe, you run it, and then what you do is you go in and you run sweeps. Just one, and you sweep it over, tilt it over, and that's now you got a swing on it, and you only got 2 fittings, and everything transfers easy. You don't keep on putting Marlex on it. That's like putting too many wire nuts. Okay? Is everybody okay with that? So I'm trying to give you the similar between them two. Yeah?
For the electricity, if you have a solid wire from the box to the cellular or controller,
Yeah.
if you have 100 feet compared to 1,000 feet, is the ohm change or is it going to remain the same?
It changes. The wire stays the same until you start putting wire nuts on it. The more wire nuts you put on it, just like the more fittings you would put. But you can run it, I mean, I've got it where it's just a little bit dropping on 1,000 feet. You know, but it depends how you bend it. You should, on all your corners, when you hit the end, you sweep, you turn it, and you go around this way. You don't take a piece of rebar in all your 90s and yank it real hard and try to get a couple more inches of your wire. You're supposed to come down, make a loop, and then go back down so you have some slack. When you put the wire inside of a trench, you're supposed to leave it loosely inside. Because if I was in Arizona, right, Arizona, and I got the wire in the back of my truck, it's all hot, it's 108, 110, and now I shove it and I bury it in a cold trench, there's shrinkage. You ever see the wire nuts like this and all of a sudden it's stressed? Because it was hot out when they put it in, when they buried it, it became cold, and then it now pulled on the wire nut. And the same thing happens with your fittings. You now do a repair, you dig it up, you cut everything, and you're going, wow, it's kind of turned. What happened to it? Is because when they landscaped, everything was an open trench. And then when they buried it, it got cold, the pipe got cold, so especially in Arizona, that pipe, you can't leave it out, right? You got to cover it. You get it and it's 110 consistently, and you leave the pipe on top of your truck, it makes it brittle like glass. You can just drop it off your pipe and it'll just shatter. It makes it brown. It takes the UV right out of it. Same thing, when you get pipe and you have it on your truck and it gets way too hot. We don't get that kind of heat here in Southern California. Arizona, Las Vegas, they have to keep the pipe wrapped up, cool, in under shade cloth and everything else, or the pipe turns brittle. Any other questions?
Just wanted to add something. It's just like this diagram shows, it's like piping, right? So if we have a long run of pipe, is my pressure going to be lower? The longer it is, it's the same. So as the wire gets longer, the resistance is going to be a little bit higher, and it's going to drop the voltage, which is like the pressure. So we need to have a certain amount of voltage to keep the solenoid working. So the longer that run is, the bigger the wire needs to be. That's why residential, we have the little wires cheaper, right? Because we're
The
not going
16
very
to
far.
18 gauge, you got the clock in the garage and the valves are like right around the corner.
There is an
So you can use,
there's
you know,
an equation to
jacketed
do
wire.
depending on how much voltage you have available and how long it is, how long the run is, and the size of the wire. 1,000 feet, you're okay.
Like, let's say average nodes in let's say 100 feet. So your bar, not the average.
That's nothing. It really won't change. I'm talking like a cemetery or a golf course or a huge park, and you're running a long way. Then now you're looking, you've got to make some different calculations.
You'll see, Richard will cover it, but it's the solenoid, because it's so much copper wire bound up in it, that's where we get our voltage drop.
That's where you get the pulling on the solenoid. Because it always on the side of the solenoid, it says inrush and it says holding. And that's on the solenoid. That's why if you buy a cheap little solenoid and you get too far, it won't pull. Say for instance, you know, for you to know, you have a Rainbird solenoid. You go out in the field with Rainbird. So let me go back over
Really
here.
good slide for that.
What's that? There's a slide coming up on
Yeah,
that?
so that really good.
So you know the AC, the DC, okay, and the resistance. So the omega sign, the upside down horseshoe, is your resistance. How much resistance, if I have the pipe and it's downsizing and it's changing, that's what we need to know, is how many wire nuts are on that run that's creating resistance in the field, okay? So that's an important thing. You don't, it's not just 24 volts. You've always got to check your resistance in the field, okay? So if you did it, I mean, in our classes that we normally do, everybody's got a clock in front of them. Everybody's got everything in front of them and they have to do each step. We just can't do that here. They don't give us enough time to spend that time and go deep with it. But everybody, you put it in, you got 121, you got 118, right? If it gets up to be 140 or 160, we know we got a problem, okay? The transformer's acting up, okay? If it's lower, real low, right out of the transformer, you got a bad transformer. So when you check it and you go, hey, the transformer, so normally everybody would have a clock, and a 100 clock or some clock in front of them, and we would check it. If it was too high, then we now are putting, it's coming in, it's putting out, and now we're going to heat up the solenoids too much, too quick. Okay, so then we put it on AC, we check our transformer, just like that. It's an Irrigator clock, it's pretty simple, okay? Normally we would be able to let you do this, but we have enough tools, I mean, for 100 people, but we don't have that kind of time. So then you check your stations, you have it on AC, so it's just going out, you're checking 1, checking 2, manual 1, manual 2, manual 3. To make sure that it's not the clock. We got to eliminate the clock, that it's not a capacitor or a triac or something else. So if you called me and told me, number 7, 1 and 7, 2 and 7, 3 and 7, number 7 keeps on coming on, in the back of an Irrigator or anybody's clock, there's a capacitor, a triac, there's several parts that protect the microprocessor that's in the clock. And what you've done is you overheated and knocked it out, and it's kind of like a triac would be like a gate valve. It's always open or always closed. So no matter what, you go, hey, no matter what, I put on 1 and 7, 2 and 7, 3, 19 and 7. 7's always on. You take the wire off, move it over another one, and then check it there, you know it's a clock problem. It's not a field problem. So I'm just, when I process something, I want to eliminate in minutes, within 3 minutes, I want to eliminate it's not the clock. It's not the transformer. I've checked all the ohms out in the field. All you have to do is put your ohm meter on. You put the comment on the comment and just check each one. Boom, 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 boom. Each one. And you don't have to go out in the field and check any solenoids. If everything's reading, we normally give you a card in our class. There's a little business card that's laminated, and it tells you an ohms reading of every solenoid in the field, brand new, what it's going to be. So then all you have to do is hold up the card, and you're looking at it and going, okay, it's Rainbird, or it's Superior, or it's Griswold, and you can check each one. Okay, 23, 23, 24, 23, 26, it's fine. Oh, 80. You know there's a problem with that station. So I can check everything. Yes?
Do you have to have are you running each station like a 2-minute test as you're doing this, or all?
No, you're just checking the ohms.
So everything is off?
Everything's off on the clock. So I got my Irrigator 24 station, and everything's off. You don't have to put it on. All you do is just put it to the ohms reading, and then you put the wire, like the black or the red, and you put it there on the common, and then I just touch it. Touch, 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 all the way down. And when I touch it, it goes down, goes all the way down, all the wire nuts, wraps around the solenoid, and comes back and tells me how good is that wire run. How many wire, if I go to the field, okay, so then if I have that problem, and then I go to the field and I cut the wires because it was 80, and then I put my ohm meter on it, I check it again, and it's 32 or 24. It's not the solenoid. That's a bad connection in between the clock and the valve. So it's not now a valve problem. I go to the next junction box where all the wires are connected together, and I cut into that and check it and go, okay, process of elimination, like eating a little whale, just ting, 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 like a little Pac-Man. I go to the next junction box and I open it up, I cut the wire, tone it out, and I go, okay, that's number 19. I check number 19 from there to the valve. Hey, that's good. Okay, from here to there, that's good. I go to the next one, how many junction boxes there are, or whatever. Then all of a sudden I've come from this side and this side and now I am between this area. That's where the wire break is. You want to tone out and use your multimeter as much as possible. Don't be so fast at opening up that 521, because you can waste a lot of time that's unnecessary opening up the 521 and tracking, where I can do a lot on the multimeter and the toner itself. I want to get it where I go, hey, it's between that junction box and that junction box. It's in between there. If I just want to show you the client, I go, hey, I can just take a wire and loop it up on top, see it working. So we know the wire breaks there. Your option now, in an hour and 15 minutes, I found them. Do you want to have one of your guys dig this, or do you want me to wire track and then pinpoint it down to the exact in between there? And a lot of people say, pinpoint it as close as possible, I'll have somebody else dig it. You know, now that you're in your like 60s and 70s like me, I mean, I want to pinpoint it with marking paint, go, hey, there's your break, there's your nick, there's where the gopher went, that's where it is, you dig it. It's there. You know, you want to get somebody at 15 bucks an hour, you know, 18 bucks an hour to do your digging. Okay? So here's your shorts. I don't have enough cards because if you take the class, we'll give you the cards for these. It tells you the 0 to ohms test, that you got a bad solenoid. When you start getting into the high numbers, infinity, if that thing and you put the meter on it and it goes up really high, then you know it'll go to infinity. You're thinking, okay, I know something's wrong. So if I just take it and then put one on one side and one on the other, and it's now like 300, I know there's something wrong. That's obviously, you know. So there's something wrong on that. So we have a little business card, and we put little troubleshooting stuff. It's called tech tips, and they're little laminated cards, and then you can just take the ring and go, okay, this is the home reading this. So sometimes you want to show the client. If I doing a house, I pull up and I go, hey, I'm just checking your clock. I just put it on there, do an ohms reading, bing, 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 bing. And she goes, how do you know that this one? I go, see this one right here? This is in the 80s, 90s. There's something wrong. So then she can tell her husband, oh, there's something wrong. There's some solenoid problems in the field. I go, pay me now, pay me later. I can make it work temporarily, but you're going to call me back in 3 months telling me these solenoids are bad. So when I had my guys go out, I used to tell them, hey, check everything, make them aware of it, because you had a check sheet, right? And if they just say, hey, just make it work. I only want to pay you just this little amount. I go, okay. But everything else, you got 9 other solenoids. If you had a 24, they're going to potentially go bad. I'm letting you know, because I don't want you to call me back 3 months from now and be all pissed off, your husband says, or somebody says, you didn't fix it completely. So I write down the ohms reading on a little chart. Boom, 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 boom. Hey, these ones are high. And they'll go, oh, okay. I mean, I've told people before, see, I used to have my techs go out, and if they could enhance the sale, they got more money. You know, I paid my technicians pretty good, so I would say, hey, if they let them warn them, and if they don't want to do it, fine. But if you say, hey, you know what, I'll put these solenoids on, and I'll give you, what you want me to do is spread it over 3 months, 6 months, I'll just break it into smaller pieces. I want to leave here and make sure you're happy and your solenoids are fixed. I'll go ahead and dice up that bill. How much can you pay? 50 bucks? Okay, I'll divide it up into, it's going to be $150 more. I'll just $50 a month for the next 3 months. But I mean, everything worked because I didn't want to have to come back. But I was one of those guys when I did maintenance in the early 70s, I'd say, hey, I don't want to mow dirt. You know, they'd say, hey, we're paying you $3,000 a month. What do you give a shit? I go, my truck with my name is out front of that building. I don't want to have that job. I will just pay and then work it into your price. What do you got? So I always used to tell people, let me fix all of it. What'd you fire the guy for? Well, none of the wires work. And then you'd give them a bid, and they'd say, hey, this is $12,000, $13,000. They go, oh, we don't have that kind of money. And I'd say, well, let me just fix it, and I'll just put it in. You want a 1-year plan, 2-year plan? I'll just mix it in. Because if I'm here, I want to fix it and be done with it. So I just fix and wire trap. I did Riverside National Cemetery. I mean, we were there for 4 months fixing stuff. And it's because what they did is every time they dug a grave, they break wires. They never had it, so all my guys, they couldn't hire anybody because no one wanted to step on. They felt like they were stepping on somebody. I go, well, hey, you know, in my case, I think they're in heaven. Maybe I'm a dreamer. I'm hoping they're not in hell and going to grab my leg and suck me down, but I'm just like, hey, you know, I'm hoping they were good on this earth and went to heaven. So I'm just stepping there, and the wires would be right across, and they would shave them. And that's what would happen with the backhoe. And I'd be like, oh my God. So then we'd fix them and then have a whole bundle. But I would shrink wrap them and then fix the whole thing. When I put in my class, my advanced wire tracking, we take all the wires and I slide a sleeve over, take it and then hit it with a lighter or a torch, and I shrink it all and make it tight so it never has to, it's bonded it back together. You're checking your ohms, see your resistance, just boom, 24, 26, 20. You can show the client right there at the restaurant. Hey, Mr. Burger King, Carl's Jr., look at, I'm telling you right here, this is what's wrong. Oh, okay. You need to replace that solenoid. You need to fix that because the wire nuts are bad. Oh, okay. And I always cut the wire nuts off because I know I repaired it. You know, I just go, who was here last? Look at it, they're falling off. I go, I'm not trying to ding you for $5 a wire nut. You know, this was back a long time ago. I just charged $5 a wire. And I said, but I know my repair work, and if I'm going to give you a warranty, I want to make sure that that was mine. I did it. That wasn't somebody else's work. I know what I will do. I don't know what everybody else will do. So all you have to do is take the black one, touch the common, and just test all your wires. Boom, you're done. That's how fast it is. And you can check and say, hey, all your solenoids are good, but this one and this one, you're okay. Okay?
And again, that's with the power off.
Again, yeah, absolutely. No power, no nothing. You got a college or you're at the city saying, man, you just want to check the whole park right now, you know, boom. I've got, you know, a couple 24s or 36s. I'm just ding, 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 ding. And what do you guys have out there, like Rainmaster or Weather Track? Yeah, I mean, bam, you're quick. You got it inside of an enclosure. You're just touching. And then I just have my regular sheet, and I put it in a plastic. I just take a dry eraser marker, boom, 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 put it down. So it makes it really quick, because then you can be proactive in the field. So if I'm working for the city of Santa Clarita, see what happens when you sit up front? No, but that I'm all like, hey, you know what? All my solenoids are good, but you know what? I noticed last time we were here, we checked that they were starting to raise. So I might ask my purchasing agent, next time when you place an order with Mr. Distributor, we're going to need 7 or 8 new solenoids because I checked it, it went up. I checked it, it went up. I guarantee it's been 8 months. I'm going to check it. Those couple solenoids are getting worse and worse and worse. And you know what's going to happen. They're going to fail on Christmas or Thanksgiving holiday, and then you're going to be called out. So when you check your solenoid, you just got a solenoid sitting on the table. And you can go ahead and check it right there. So now if I go out, and I always check my ohms. If you go in at any distributor, walk over, grab a Rainbird anti-siphon valve. Grab a Rainbird DV valve. Grab a Rainbird scrubber valve. Okay? Set them all on the table, take it and check all the ohms on them. They'll be different. Because if you got an anti-siphon valve, they're usually pretty close to the clock. The clock's in the garage, anti-siphon valve's right on the other side. If you get 200-300 feet away, it won't work. Because you'll check the ohms reading, they'll all be in the 50s and 60s, right out of the box. Okay? But if you get and what it will be is a black wire with a white stripe on it. When you buy Rainbird's commercial solenoid, it'll be a white wire with a black stripe, the opposite. So if you think, oh, it's Sunday or Saturday, and I'm just going to go into Home Depot, you know, Mr. So-and-so distributor's ripping me off, man, I can go into Home Depot and get that solenoid for $18. I go into my turf distributor, and they're charging me $28, $30. Why is it so much? It's because they're selling you the commercial one. They're not selling you the retail one. So don't think, hey, I'm going to go in, buy an anti-siphon valve, take the solenoid off. I get an anti-siphon valve for $12. I'm going to take the solenoid off instead of buying the solenoid for $36. And I'm going to change that solenoid. The ohms is going to be higher. So always make sure you buy commercial solenoids. Check your solenoids all the time. I've even got them right out of a box. I check them, and I've had them go high, and I go, hey, give this to somebody else. You know, I don't want it. Okay? So make sure you always check your ohms when you're putting a solenoid in. So these are like your little direct burial DBYs. Why do we coil up the wires like that? To have extra wire? So you can cut them off and go get some beer later or something? What you do is right in the specs, an irrigation consultant or an architect will say, take a 12-inch pipe, nipple and then wrap it around. That's what you're doing, right? And then you pull out the nipple and you got a nice coil of wire. Okay? That is exactly a semiconductor. When electricity travels, it spins. And when it spins, if I go on the field and I got a lot of nicks in the wire, every time I replace a nick, I coil up maybe 14 inches. So instead of 12, I'll go, quite a bit. I just wrap the pipe around a 1/2-inch pipe and then pull the pipe out. The farther I run it on a golf course, they'll go 24 inches. Every time you put a wire in, you should coil it up like that, because what it does is electricity travels through, it spins, and then it pulls the plunger in. It gets a better kick to it because you're coiling up the wire. I had a job, it was a Rainmaster job. It was right where Brandon lives in Ranch Cucamonga, in the corner right there where the spaghetti factory is. I was out there, Scott Kyle called me up, and I was able to get there before him. And there's a Home Depot there. Somebody went right through the light, hit the box. And when they hit the box, the electricity goes poof, and it goes out. Most of the solenoids were all gone. But anything that had a coiled wire like that, it absorbed it and didn't burn up the solenoid or do anything to it. So anytime that when you're traveling electricity, you want to coil up the wire. Okay? Everybody okay with that? So that's why it's there. You're always thinking, why is it coiled up? All new construction, you'll always see it coiled up like that. And DBYs are good. Anything where it locks in. What the gel cap is, it really doesn't matter, the name brand. I just want to make sure it's not loose. Like the dry sack, you take that on and then you take a little cinch tie and pull on it. I don't want anything coming off. I do not want to bury it and have to come back when I give a warranty on it. I'm not going to go back up and dig that 3-foot hole again and go, oh my God. So what I do is just like when we're inside the walls here, it doesn't matter if we're in California and Chicago. We cannot leave an open wound of a wire inside there. They put a junction box. So every single time when you fix a wire, you should always take it, run the extra wire, pull it up, put a 6-inch valve box, and then have it right there. Dawn fittings, you go out there, they got a little top where it fits into a 2-inch pipe, and it snaps and it grabs and holds onto the wire. And what you do is you just take that up, put it in a 6-inch valve box, put a gravel pit, and pull your wire. Because now I got a point of connection there. I don't like to bury the wire. Once it's broke, I don't want to bury it again. Most likely, anytime that I've ever gone out, I'm fixing somebody else's brake that was 2 years earlier and it came apart, or it overheated, or something else happened. But if I take it, put a drain pipe and pull it up and put a 6-inch box on it, now I can come back and repair it much easier. And I tag it. So if you're a certified contractor with Irrigator Tech, and if you do work for the city of Santa Ana, Mike Lopez has it written in his spec that you must have all 4 of my certificates, and we go out there for free and check all the repairs and all the install to guarantee that the work is done right, and they have to tag it. They put their certification number right on it, and I give them a little laminated card, and the laminated card goes right inside of there. But they pay their contractors better because they're certified. I want to know who does it. That's work I'm doing. I want to make sure, so we do that. And we make sure everything's tagged. Because anybody that's certified by us, we want to, it's like our alumni. I don't want some guy to take my class and then go out and keep on screwing up stuff. Hey, yeah, look at me, I got a certification from Irrigator Tech. Yeah, you've destroyed our place. I don't want to hear that. I don't want to hear that they're a backflow tester. They took my class, and then everybody in Walmart or anybody that, they all got diarrhea, they got sick, from the tester. And it's brought to you from Irrigator Tech. You're like, oh my gosh. So, no, I don't want to do that. So, any of your gel caps, has everybody got a 24B or a 24A? No, everybody should have one of those. The toner, if you're a wire tracker, you should have a 24B. Does anybody get Rainbird points and Hunter points, and they're all on the points program? I would use you're on that. Make sure you have the right tools, man. You guys all buy Hunter, you all buy Rainbird, you buy Hydro Rain, Dura, all those PVC fittings. If you're a member of Irrigator Tech, we track all your purchases and get you 5 to 10% rebate back in points. Because I want all my members to have the right tools. So all these tools you should be getting using your Hunter, your Rainbird points, your Hydro Rain points. You go to Hydro Rain, you look, they give you 10% rebate. So you go to any distributor, buy, you're getting a good price. They send in that information from Hydroscape. They send it right directly to Hydro Rain, and then you'll get a letter saying how many points you get. All that money adds up, you get free tools. So you get a credit, you get it, you go back into Hydroscape, and you get a credit on your account. Now you got a 24B. There's no excuse not to have good tools when these people are giving you points for stuff. So Hunter, Rainbird, all those people give you points, and now you should have the best wire tracking tools, the best stuff in the industry by having all those points. And you can go to Hunter and Rainbird and Hydro Rain and tell them, hey, that fat guy that taught the class this morning said you can do that. So you want to use your tester here so you can use it and put it on the transformer. Now, these are your capacitors right here. These are going to be your triacs right here. So these are the things that are giving you your protection for your microprocessor. Your microprocessor is going to be in the board, protected, and these are our layers of protection when the solenoid goes bad. But you can take your 24B and then check this for your voltage. It works similar to a multimeter, but it doesn't give you the right, the exact readings in the field. Hey, how you doing?
Right.
This guy right over here took my class, backflow, right? He's been doing it how many years? 6 years Tony's been doing it. He's been doing great. And he worked for the school district, and now he's retired doing backflow testing. So you take your 24B or 24A, you can give 24 volts right to your valve. So after you change the solenoid, before you hook it up and drive away, you want to test stuff and make sure it works with your tester. So it's a great little tool to have. Every distributor has them. Amada makes them, and so does Greenleaf. So those are great things. Everybody should have one on their truck. How are we doing on time?
20 minutes.
How many? We got 10 minutes? 20 minutes. Okay, I'll move a little quicker. Okay, so is there any questions that you guys have that I'm not answering, or should I just keep on going? Keep on going, okay? So you can check your transformer with it. So what you're going to do is a toner and receiver, which Brandon has passed around, you should be able to see. So one checks it, a 77A, and then the other one takes the receiving. So it goes boom. So now if I have a tree that falls down, got hit, or it died, right now with us with the drought, I mean, we don't even know what's going to happen. What at UC Irvine, aren't you guys having all sorts of problems with all the trees out there? And, I mean, hundreds of them. They got some freaking crazy-ass beetle that went nuts out there. You didn't think I knew. See, I know all that stuff. I'm fun. I track you guys everywhere. But, I mean, just, you never know how many great, awesome trees are now going to die because of the drought, because we're not, well, let's just turn it off. The grass, we could get to come back pretty easy. When you got, I mean, they were like marked one of the number 1,000 trees on campus, and I mean, UC Irvine's awesome, and they have great trees. It's a shame that they're having all this insects tearing them up right now, and it's because you didn't have the problems when we were actually giving water to the trees. Now you got insects coming in, all sorts of crazy things happen to landscape when we start pulling back the water. But if they had to take a tree down and a guy stump grinds, takes the stump out, and now you have 20, 30 wires here, 20, 30 wires there. You need to tone them. You can't just shove them all back. So what you do is you stump grind, pull it all up, and you get on one side, you get on the other side, and then you put those wires together, and then you go, okay, what do you want? Toning, 1, 2, 3. You just go back and forth, and you move it. Hey, it was 17. You take it off 17. Where do you want it to be? I want it to be 12. You go, boom, back and forth. Is that Hat back there?
Yes, sir.
Wow. You know Kellogg?
Just auditing your class here.
You know Kellogg? Molds and stuff? This guy owns Kellogg right here. That his family. That guy's famous right there. You should always use Kellogg product, and he is.
What a great concern.
It's awesome. No, I just think it's neat. You know, you go to Home Depot, Lowe's, everywhere, and I'm like, I know that guy. That's so awesome to see him walking around. That's cool. So we put him in the Green Industry Hall of Fame.
Thanks for all you do.
So now you're toning back and forth. That is a great tool to have, so you're toning those wires back and forth. So from junction box to junction box, I'm at one junction box and I go, okay, I open it up and I got 24 wires. Which one's 17? You go back to the clock and you hook up that, you go over there and you go, that's the one that's 17. You don't just cut all 17 wires. You want to tone out the one that you have, right? Okay, so this is an awesome tool. Everybody should have one of these tools in the field. So you go back and you say, hey, I buy Rainbird Hunter, Hydro Rain, anything that gives you a point. Use the points to get nice tools like this. And then I can be at the valve box. I'm way out in the place, I go, I don't even know what number. A lot of valve boxes, they don't put the numbers on top. So you go, what is this? Well, I don't know, it's 17, maybe 19, maybe 21. So you hook it up over there, you go back to the clock, real loud, you go, hey, I guess it's 19. You take your little thing and mark it. So when I'm doing a shopping center, if I was maintaining a shopping center and I'm now just taking it over, I'm going to say, I'm going to water the parking lot. So I'm at Walmart, I'm looking, I'm going to go, I want 1 here, I want 2 here, I want 3, 4. I want to finish everything the public's going to touch or get their cars wet so they don't sue you, right? They pull up in their fancy, nice new car that just got washed and then the sprinklers come on. So I want to get everything watered first thing in the morning, and then behind the shopping center on the hillsides, I let it come on at 8 or 9. But I mean, at 1 in the morning or 2 or whenever you're going to water, you want it to come on. Plus, if I'm going to do a walkthrough in a park or a homeowners association, I want to walk down and go 1, 2, 3, 4, and know exactly where every station is, and I'm walking on a circle. Does it look like I want to walk? No, I'm a little heavy, okay? Just a little heavy, okay? So then I want to be able to walk and say, I'm on station 1, station 2, I don't want it to be up on the hill. Station 3 behind the trash cans. No, I move them. So now you just go where your terminal strip is and go, I want this to be 1. I want this to be 2, and untake off 7 or 9 and move it over. So 1, 2, 3. I can walk the whole place and make sure that the property looks nice. If I was maintaining, you got a football field or a soccer field, I don't want 1 to be here, and then 2 to be down the hill, and then 3, I want it to go 1, 2, 3, and the whole, and it just goes down. Those 5 stations do the whole soccer field, right? You don't want them to be off all over the place. So all you do is tone out, come back, each time. So that's how you do it with a toner and receiver. Yeah?
Is there a distance the toner to go?
No, I've been on the freeway and been 5 miles down. I wire tracked a ton in the 90s on the freeways, and I could take my receiver with a thing, stick it outside the window and shove it in, and it'd go beep, and it would kick me down. I go, hey, move slow. I didn't want to get out of the truck. There's a lunatic drivers out there. So I would just beep, and then I would tone out. And what they'd have is I'd dig up these, so the hill would slide down and just cover the whole valve box. And they go, we knew it was around here somewhere, but the ice plant or everything else. So then I would tone things out, and I'd be 3, 4 miles down. And it's still, so I mean, you can use this. It's great for the phone industry. You ever see where that has that little phone thing? So you can hook it up to your phones. You can use it for any kind of electronics. It doesn't know if you're working on a car or a trailer. It's still sending that tone. It doesn't say, oh, no, you're not irrigation. I'm not going to work. You know, it's going to go, whatever you send the tone down, I am going to go through. Okay? This is the old 521. Now, that's this one right here that we have. Then you got the longer box, too. Okay? So does everybody own one of these or got one? They're great. You have the 521 or you have the model one?
I can't remember the model. It was like $300 on online.
That's pretty cheap.
Yeah.
That's pretty
It's on
cheap.
sale.
It's on sale. It just fell off someone's truck. No, I'm just kidding. $300! Oh, and it came in a box and everything. My God, I got a van out front. I'm selling some stuff too. No, but so these are usually between $600 to $800. So $300, you could have bought a couple of them, you know. They hold up pretty good. So what you're doing is taking the red wire and hooking it to the wire that's on the clock. You always got to remove it from the clock. Okay, don't clamp it onto the little screw holding it. Okay, because you'll toast the clock real easy. So you bend the wire, take it out, clamp it on that, and then you got a ground one. Okay, that ground stake is super important. If you can't get it because the soil's so hard, like a rock, and you cannot get it in, don't wire track. I tell people, hey, soak it, and I will come tomorrow and wire track. You want to be able to put that stake in and slide it right in the soil. Because a wound, like basically it is, a gopher comes over, chews on the wire, takes it, opens a wound. When it's going, like someone's doing over there, okay, it's making that noise, it's bleeding out. And if it's moist, it bounces back and forth to this stake. To the wire, to the stake, to the wire, to the stake, to the wire, to the stake. That's how it works. If that's sitting loose or in dry soil or sandy, bad connection. You cannot be in Burger King, McDonald's, and the clock's there, and then you just hook it to a ground right there. No, that doesn't work. You take a 14-gauge wire, clamp it on that, and run it outside and stick it in the dirt. You can't just use a regular ground. Because this type of ground that's what you're bouncing the nick off of to go back and forth. Okay, so you can't use any other kind of ground. You know, I'll take a piece of rebar. I have a lot of rebar, and I'll take it, sharpen the end of it, and I'll just beat it into the ground so I can get a good connection so it's solid. Then I'll clamp it onto that. But if it's loose, yeah, I wouldn't do it. I would soak the area everywhere it's at because you can wire track much easier. If I have to put a battery-operated unit on it because I don't want to lose the maintenance and I'm just going to go, hey, you know what, these people are paying me $8,000 a month, I'll put a battery operated, I'll wait till it's November and go back and wire track because it's soft, it's raining. Normally it's raining except here in California. Okay, but we normally want it to be really soft, so people will say if I'm working for the city of Santa Cruz, hey, I've got about 17 wire breaks. I got all battery operated units. I'm waiting till December, November when the work levels maybe down a little bit, and then I'll go back out and wire track under a calm environment, no one's screaming and freaking out because the baseball field's dying or the soccer field or a brown spot, and then I'll come back and wire track. So battery operated units buy me time so I can now do it. You guys are both, do you just do irrigation or troubleshooting?
Low voltage lighting.
Oh, okay, well, you know, I mean, with doing that, you can get overwhelmed with lots of wire tracking work. It's much easier to put a battery on. Hey, I'm booked right now for 2 weeks, but I'm going to put a battery-operated unit. I'll be back. I'm not going to let your plant material die. I want your flowers looking nice at the entry. It's just I'm booked for 2 weeks because I think we're just great guys, you know. So you're not brothers, right? No, not a dad. No, I'm just kidding. He's all, what? No. So red goes to one, black goes to the other. When you're over the top of the wire, it's a null, which is quiet. Okay? So with the 521, it's kind of weird. You're listening for the silence. Okay? With the Amada one, the 600, 800, the one that's at the end of the table, you're walking to the noise, which is sometimes you got the right brain, left brain. Sometimes it can be easier to walk to noise than not walk listening. Where am I going? I'm listening for silence. I hear nothing. You know, so you're like, where is it? I don't know. So you're walking, and you normally have to walk away from where your clock and it's hooked up. I normally go 5, 10, 15 feet away, and then I go in a circular motion trying to pick it up. It's all quiet. Okay, quiet. And if anybody's wire tracking and moving like this, then you know that person doesn't know what the hell they're doing. You don't wave. You're just going the wrist like this. It's just a little on-off, on-off, on-off. Very short. If someone's pointing at a hillside, yeah, I can find it. I know it. It's out there somewhere. You go, oh, that guy's just killing time. You know? So, I mean, it's normally just a little, and you're moving slow. There is no fast process. If they say you got an hour, that I'm the homeowners association, that's all you got, you just go, hey, give it. There's no way that I'm going to find it, dig it, repair it, and do a proper job and What is it, just some lucky random shot of gambling that be able to find it? I mean, that's pretty damn lucky. If I took 10 jobs, maybe one that you'd be able to do that with. The rest, it's a struggle. Wire tracking is not easy. And that's why I always tell everybody, every company that charges for wire tracking, charge your $45 to $65 an hour for fixing sprinkler heads and valves. But if you're wire tracking, make it 100. Because it doesn't just come easy. You got to be methodically thinking and being like Columbo. Most of you guys don't even know, but that was a detective a long time ago. Well, you two guys don't know. But some of us older people know detectives, you know, but that was, you know, you guys are like in your 20s or something? Yeah. Me and this guy right here, you might know. You know, yeah. You know, there's somebody old here. So it's noise. Then what you're doing is you're catching it, and then it goes over to 10. And then remember, don't always set it all the way to high. So if you got this one, you got 0 to 5 right here, right? A lot of people just put it right over to 5. Okay? I got a headache, why take 2 aspirin when I can take like 19 and make that headache go away right away? You know, you don't do that, you know? The best way to get rid, I mean, if you're going to take some aspirin, you crush it, stick it underneath your tongue, and it absorbs, it makes your headache go away faster. Okay? But with this, in this case, what you do, why am I making someone go to sleep? Jeez. Okay. No. What you do is you set it over to 1 or 2, and then you've got this going here. So you pop this out. I've got this hooked up. I got the headset. Now, when I'm going away from it and I'm moving back and forth, this has got to bounce here. Then this is going. If I set this on 1, say I go to 2, if this doesn't kick me over and get me up to 10, then I know I have to kick it up again. Okay? So what I do is I set it, this is a good thing to remember, is I set it, say you had 1,000 feet of wire, and I put it on 2, and this is barely going up. I know my battery's good, but it's barely going up, and I have to kick it to 3, and then it goes to 10. Then I know it's on that wire run, it's at the 500-foot mark. You see what I mean? It's kind of the middle of the road. If I set it on 2 or 3 and I got a strong signal, it's bouncing, it's within 50, 60 feet of me. Because it's sending that signal to the stake, and it's very close. It's bouncing back and forth. If I got to set it to 5, then it's at the end of the run. So if I have 1,000 feet and the valve box is way on the other side. Now remember, on homeowners associations in most places, it's not a straight run like maybe a park. You're behind things, you got green transformers, you got electrical everywhere, you're walking like this, you run into a pole. I mean, you've had, you know, you're like, wow. What I do, if I know where the valve box is, if I have to set it to 5 to get it to bounce, I pick up my equipment and go to the valve box. That saves me a huge amount of time of walking around streets and bumping into things. I hook it up there, and then when it's 1, I go, hey, I just saved myself 900 feet of walking and bouncing off walls and putting marking paint all over the grass everywhere. So if I have to give it a higher strength, it's at the end of the run. If I set it on 5 in a wire track, and I'm suffering going through it, I am every little nick that a rock hit or a gopher took a chunk out of, I'm going to jump over it. It's going to arc right over that nick. It's going to jump over because I got it at the highest signal, and it'll just bounce and pass over. So if I have to lower it, if I want to find little nicks, I got to lower it and really fine tune into here and there to make sure that I'm over the nick. I mean, a clean break someone took a shovel through, that's pretty easy to find because it's testing the soil. If the copper is touching the soil like a gopher eats at it, and now you got a wound that big because and it goes away. So the buzzing, you know when you hear a solenoid, the electricity, we don't hear it, but the gopher has very sensitive ears. It's going to the wire to chew on it to stop the buzzing. So he goes to the wire because it hurts his ears. He chews on it, and then all of a sudden the station goes off. He's all, hey, I must have done it. And he goes away, and you got an open wound. Okay? He'll eat at that wire until it stops buzzing. Now that open wound is the copper's touching the dirt, and that's what's bouncing from the stake to that open wound, back and forth. But if it's an old system and you got old trees like at UC Irvine, and you got oak trees and big ones, and it just stretches the wire over time and pulls it, if the break stays encapsulated in the wire, and that wire does not touch the dirt, you're not going to find it. Yeah. Oh, what time is it? 12. I guess you guys are done. Sorry, I guess he wants to leave. He's all, I'm done listening to this guy. Let's get the hell out of here. It's 12 o'clock. He's not interesting enough. Let's get out of here. No, that's fine. I mean, you can stay, ask questions of me. I mean, I'll just go on all day about wire tracking. I can talk. There's so many little minute things that you need to know. So I appreciate you guys coming, stopping. Watch our videos on the Green Industry News. We'll have this up, and we're always putting videos up that might give you a shortcut when you're stuck in the field. Enjoy all the cars, the PVC locks. Stop at Hydro Rain and see them, because I gave you a PVC lock. I gave you some wire nuts and all that stuff. Make sure you're signed in for your credits. If you want any of your certificates for the hours you put in. Oh, look at this guy from Arizona. He's not from California. He gives me back stuff.